Okay, so today we're going to do section 3, lesson 4 of the making of a scientist. Today's lesson actually is really short. So I'm going to give you a little bit more than just the Google form to do today because you should be able to get it done no problem. You're caught up with your work, which is fantastic. I'm so proud of you, but that means now you can start doing some of the other stuff your classmates are doing. So today, we're not really going to continue reading. We're actually going to take another look at one of the diagrams and one of the captions in the 13 Planet books. Because what we're going to do is we are going to figure out how Aguilar, who is the author of the 13 Planets books, translates information so that way we can understand it. So while we're looking at this, um, I really just want you to focus on the caption and what it's saying and compare it to the diagram. All right, so we're looking at page 10 and 11. So if you look, and I'm not even going to reread the whole amount of text, I just want you to look at this diagram. So it's a diagram of our solar system, but obviously these are not the actual sizes of the planets. But if you look, you can tell, like, here's Jupiter and it's massive. And then here's Mars. Here's the dwarf planet Ceres, is that little dot right there. Here's us on Earth with our moon, Venus, Mercury, all that stuff. And then if we go to the other half of it, we've got Saturn, which is nearly just as big as Jupiter, Uranus, Neptune, and then here's Pluto, all the way over here in the Kuiper Belt. So this is a diagram of our solar system, and the sizes of the planets are what is called to scale, meaning that when Aguilar shrunk the planets to make them fit on the page, he shrunk them all by the same amount. So you could really compare the planets and see what they look like compared to the other planets. But something he couldn't do was do the distances accurately. If we go back up here and we take a look at Jupiter, if Jupiter was actually this close to Earth, we wouldn't be able to see anything in the sky but Jupiter. So the distances are not to scale. And that is because if you remember from the Pluto video, if we actually did the distances to scale, then Jupiter would have been the size of a bacterium and Pluto would have been the size of an atom. So there's really no way to accurately put the distances to scale and still be able to see the planets. So now all of that being said, let's take a look at this caption. And we are over here with this caption right here. And it says, this artwork shows the relative sizes of the 13 planets, but not the distance between them. And again, we said that was because there was no way to do that. Using the planet sizes shown here, the sun would be about 40 inches in diameter, and dwarf planet Aries would be some 7,750 yards away. That's 580 large school buses lined up bumper to bumper, or 77 football fields. So, what did he compare the distances of the planets to? So, we can't see it, so he translated it so we would be able to understand it. And what did he compare them to? He compared them to school buses and football fields. And that is actually a really common measurement that authors will use because everybody knows what a football field looks like. Everybody knows what a school bus looks like. So it's something that we know that we can compare it to easily. So, all of that being said, so how did Aguilar translate the distances between the planets into some reality like Feynman's father taught him to do in The Making of a Scientist? Well, Feynman's father, with the dinosaur example, he compared the Tyrannosaurus rex to the house. He compared that dinosaur, the unknown object, to something that Feynman understood, like his house. In the 13 Planets book, Aguilar decided to compare something unknown, like the distances between the planets, to something we did know, school buses and football fields. So, how are these things? So then we're not going to answer that question. I don't like that question. I don't know why I put it in there. We're not going to answer it. So, how are those two things similar? How are Feynman's father comparing the dinosaur in the house and Aguilar comparing the planets to school buses and to football fields? How are those two things similar? Well, it's because both people took something unknown and compared it to something that people knew well. So, this is the question that you are going to be answering on Google Classroom. And it says, who do you think does a better job of translating information, Feynman or Aguilar? Now, this can be anybody you want, okay? Because this is your opinion. It's an opinion question. Feynman or Aguilar. I don't care which one. If you want to say both of them did an equal job, that's fine. But the important thing is I want to know who you think did a better job and why you think that. I'm not going to give you full points if you don't tell me why you think that, okay? So go ahead to the Google Classroom and get started on that Google form. When you are done, if you are done with Mr. Boston's workbook, there will be a nice little list of things for you to do on Google Classroom. And I will see you soon. Miss you, buddy.